Hello, welcome to Multivariable Land. Now I'm going to talk about something about partial derivative. Here I have h of x t equals e to the negative 3t times sine of x plus 5t, and it's asking for the differential for h of x t. Well, what's the differential? Let's say differential is dh, which is hx of xt times dx plus ht of xt times dt. So how can we apply this into h of xt over here? So one thing you notice that if you're doing the h of x of xt, t is constant. So which means hx of xt will be so simple as e to the negative 3t, which is a constant. And derivative of sine will be cosine. Cosine of x plus 5t. You don't have to time the chain rule, but if you go with the chain rule, the derivative of x plus 5t is 1. So it's just this. h of t is of x of t is relatively more complicated, but it's not that complicated. You can have to use the product rule, which because it's two functions of t. So say the derivative of the first one, which is negative 3 e negative 3t times sine of x plus 5t, and plus the first one times the derivative of the second one, which is negative 3t times, since x is a constant, you don't need anything, but 5t plus x, you need times cosine of x plus 5t. According to the chain rule, you need times 5 because t is a variable in this case. Then you have rewrite this a little bit. Let's just rewrite this as negative 3 e negative 3t times sine of x plus 5t plus e to the negative 3t times cosine of x plus 5 cosine x plus 5t. Now we have to do is just plug this back in, which will give us the whole thing, cosine x plus 5t. Remember this is the partial derivative of x, so this is times dx plus this whole thing right here times dt. I'll make it a little bit simpler if I just go with take out the e to the negative 3t, so you have e to the negative 3t in front, 5 cosine of x plus 5t minus 3 sine of x plus 5t. This whole thing times dt. So this really long and really ugly is the differential for h of xt. Thanks for watching.